Done by now. If you're not, that means we need some help. So somebody tell me, what is the oxidation state of manganese in KMnO4?
+7.
+7. How'd you get that, Michael?
K is +1.
Okay. How do you know that K is +1?
Location on the periodic table.
All alkali metals are +1. Plus, if you look at the symbol, there's a little number 1 above the symbol. That's its oxidation state. That's going to be its charge. Okay, but all alkali metals are 1. What are all alkaline earth metals?
1.
Group 2 are all going to be what? 2 plus 2. Only possible charge. All right, so what's the next step, Michael?
You know the oxygen is -2.
Okay, and you got 4 of them, so it's
-8.
and it always has to add up to
0.
0. Now, how did I know that this wasn't an ion?
There's no charge on it.
There's no charge. An ion is a charge. By definition, it has a charge. This is an ion. If it's not an ion, it's going to have a charge written. If there's nothing written, no charge written, we assume it's 0. It's a compound. So therefore, heavy-duty math here. We can do this in our head. Manganese must be +7. Okay? So now, somebody else tell me, how do I do this one? Go ahead. You like?
So for hydrogen is +1 oxidation,
Okay?
and you have to do -2 for oxygen, but because there are 4 of the oxygens, it's -8.
Okay?
And it has to equal to -1 because there's a negative charge.
Okay, has to equal -1. That's because of that.
Yeah. So it's going to be +6.
+6. Now, does that mean that sulfur lost 6 electrons? What does that +6 tell me? What does the oxidation state tell me?
6 electrons are involved in bonding.
6 electrons are involved in bonding. I think I got it in stereo there. 6 electrons involved in bonding. Okay? So that's why we say +6, not 6 plus. When it's an ion, when there's actually been a transfer of electrons, and you get an actual charge, that's when the sign goes at the end versus the beginning. For ionic compounds, for ions, the monatomic ions, generally doesn't matter because it's going to be one and the same. But when we're talking about the nonmetals sharing electrons, that's where it's you don't want to say 6 plus. We say +6 because it just tells us how many electrons are involved in bonding. Does everybody know how to do this? Because in order to do this next part, we have to be able to do this. We're all good. Okay, if there's anything you don't understand, I'll be glad to answer a question. All right. So now that's we laid the foundation yesterday on what we need to do. So today we're going to go through and talk about naming and writing formulas for ionic compounds. We're going to have 3 different sets of rules. One for ionic compounds, and how are we going to know it's ionic? What type of elements?
Charged. Or non-metal and metal.
Well, which one's going to be first?
Metal.
It's always going to be the metal and the non-metal. Then we're going to have a second set of rules for covalent. How are we going to know it's covalent?
2 non-metal.
2 nonmetals. Then the third one is going to be for acids. And what do we say? What ion is present in all acids?
Hydrogen.
H plus. The OH was a base. Okay, the hydroxide is the base. The H plus is an acid. Okay, so we're going to have 3 different sets of rules. Today we're going to focus strictly on ionic. Okay, hopefully we're going to get through all of that. And then on Monday, covalent, I can teach you how to name and write formulas for covalent in about 5 minutes. All right, literally. And then acids, we'll use the rest of the period. And so we'll finish all the notes on Monday. Tuesday is pretty much going to be just a practice day. Wednesday, probably a review day, and then we'll probably take a test on Thursday. Okay? It's just, there's only 4 pages of notes. It's just, you just got to practice it once we learn all the rules. Okay? So that just kind of gives you an idea of where we're going. So let's turn down page 2 of your notes, naming ionic compounds. Naming ionic compounds. So we're going to name the cation first. That's going to be your metal. Your metals are going to be your cations. Now there is one polyatomic cation, and that's ammonium. You just have to be aware of that. Ammonium is NH4+. All other cations in an ionic compound are going to be these monatomic cations, just one metal. And the name of the cation is just going to be the name of the metal. So you have sodium ion is still just going to be sodium. Calcium is still just going to be calcium. So you're just going to name it. There's no change of the suffix, nothing. It's just, you just name the metal. If it happens to be NH4+ first, then you just say ammonium, the name. Now you're always I'm about to give you a sheet here in a second of all these common ions, but you just name the ion first. Now here's the one thing that we have to pay attention to with ionic compounds. Is the only thing that makes ionic compounds more challenging is if the metal is a transition metal, with more than one possible oxidation state, you have to state the oxidation state of the metal with a Roman numeral. With a Roman numeral in parentheses. Okay? And then we name the anion last. Now, so I'm just going to put this in here. Now we're just going to look at some. Everybody, if you have the color periodic table that I gave to you, let's get that out. Not just the one in the book, because they don't have oxidation states on them. I want you to be familiar with the oxidation states. There's a microphone over here. So if we're looking up here, first off, where are your transition metals? In the middle. That is all your transition metals. Look at the little numbers above the symbols. This is real simple. If there's more than one number above the symbol, it's got more than one possible oxidation state. All right? You are not just going to have to be a swami, a psychic, and just know what the oxidation state is. We're going to have to figure that out. We're going to have to identify it with Roman numerals. If you look up here, you can see copper 1, Roman numeral 1, that's going to be copper plus 1. Copper plus 2, copper 2 is copper plus 2. The Roman numeral is going to tell you the charge. Okay? So we have to know when they have more than one. Now, how are you going to know if it has more than one? Because scandium is a transition metal. Yttrium, you have zinc, cadmium, and silver. They only have one. So how are we going to know if it has more than one or not? You're just going to have the periodic table and you're going to look. Okay? You're going to take the time just to look. That's the only way you're going to know. Okay? But I'm not making you memorize anything. You have the periodic table. You'll have it on the test. But you just got to take the time to look if the metal, and we say transition metals, but the reality is it even comes into these few over here: tin, antimony, lead, bismuth, thallium. They all have more than one too. So if it's a metal, generally it's a transition metal, but we have this little few right here that are still metals with more than one oxidation state. But the only way you know that is you look at it. It's got more than one number, it's got more than one oxidation state. So if I'm just going to name these, well, even before we get into that, and we'll practice that and see, but let's just talk about how we name these anions. Your cations are monatomic, just one atom, just ammonium. But anions, okay, here it is. I need to go right here. There are only 3 possible endings for ionic compounds: "-ide", "-ite", and "-ate". Okay? Monatomic ions. What does monatomic mean?
One atom.
One. Only one type of atom. Now you can have, FeCl2, FeCl3. That's still just one type of atom. Even though you got 2 or 3 of them, it's still just chlorine. These polyatomic ions, known as chromate, is Cr and O. Okay, hypochlorite is Cl and O. Nitrate is N and O. Monatomic is just going to be N, or just going to be Cl, or just F. Monatomic ions end in IDE. I. Okay, that's the suffix. Now there has to be exceptions. There are 2 exceptions to this. What did we learn the name of OH minus was yesterday?
H. Hydroxide.
Hydroxide, there we go. And it's right there up in the middle, right in the middle of the 3rd column, hydroxide. And then another one that you don't ever want to breathe in is cyanide. Now these end in IDE, but they're not monatomic. you'll still have the names of them, you still have them, you know, on your chart and whatever, but they're the only two that I know of that end in IDE, but they're not monatomic. But all monatomic ions end in I. Okay, so if it's just N, it'd be nitride. If it's just F, it's fluoride. If it's just O, it's oxide. Just S, it's sulfide. Now, polyatomic ions are going to end in ite or ate. Okay? Now, notice we say usually because of those two exceptions. Okay? Now, these are going to contain a nonmetal plus oxygen. Okay, so your polyatomic ions are going to be chlorine and oxygen, nitrogen and oxygen, sulfur and oxygen of some kind, in some ratio. So they'll end in ite or ate. So if it's an ite or an ate, you're going to know that there's a nonmetal plus a certain number of oxygens with it. And it follows a pattern. Okay? When I look at the 8 ending here, I go and I look at the table and I find that sulfate is SO4 2 minus. That means that SO3 2 minus is going to be called sulfite. Okay? The ite ending always means one less oxygen than the 8. So if NO3 minus is nitrate, what's nitrite going to be?
NO2 minus.
NO2 minus. Okay? So if phosphate, you look up here and you find phosphate is PO4 3 minus, what's PO3 3 minus going to be? Phosphite. Now, unfortunately, the 8 and the ite doesn't mean 8's always going to have 4 oxygens and the ite's going to have 3. That differs from element to element, but the ite is always 1 less oxygen than the 8. So if I know the 8, I know the ite. Okay? We good with that so far? Just always remember, the ite is 1 less oxygen than the 8. But then we have an issue. We only have 2 suffixes. Suffixes is 2, suffix I don't know, plural. We come here, and this is chlorate, is ClO3 minus 1. So what's chlorite going to be?
ClO2.
ClO2 minus 1. Okay? So let's just for practice, what's the oxidation state of chlorine here?
5.
Does everybody see 5? Okay, somebody else tell me. I would love a female to tell me how is it plus 5.
The oxidation state of oxygen is -2, and there's 3 of them, so it's -6.
And it has to add up
And
to?
it has to add up to -1, so chlorine's plus 5.
Okay, very good. Now, does that mean chlorine lost 5 electrons? Simply means 5 of chlorine's valence electrons are involved in bonding. What is the oxidation state of chlorine here? Plus 3. Okay, same thing, it's just there's only 2. So plus 5 and plus 3, but chlorine can also be plus 1 and plus 7. We saw that yesterday. But we're out of suffixes. So they go in and started using prefixes for these because you have to just kind of do that. So there's a prefix for below. What is a hypodermic needle mean? Under the skin, below the skin, the dermis. Okay? And you have hypoglycemia. What does that mean about your blood sugar? It's too low, right? So hypo means below. So they call this is going to be the +1 oxidation state. It's one less oxygen than the chlorite. So we're going to call it hypochlorite. Meaning it's one below the chlorite. Oxidation number is the next one down, but it's one less oxygen. So what's the prefix for above?
Hyper.
Hyper. But for some reason they dropped the high off of this one and just call it per. It's one above the chlorate. So it's perchlorate. Okay? Perchlorate. Now I don't know why they dropped it off of the hyper and they just called it per. And they didn't drop it off of here. Maybe they just didn't want you to feel sorry for the chloride, thinking you're saying, oh, chloride, or whatever. But, you know, no, thank you. At least I got smiles in this. I got zero response on that one in first period, whatever. But, so they kept it on here as hypochlorite, but the per comes from hyper, meaning above. So it's the same kind of principle, okay? Now, all of the halogens. This is just going to blow your mind right here. Okay, so follow me over here, Mike. This is just going to open up a world of opportunities. This is going to make you say, oh my, but this is not oh my information. This is testable information, but it's just amazing on the periodic table. Okay? Why are elements in the same family? Why do they call it a family?
They have the same amount of valence electrons.
Same number of valence electrons, so what does that mean about the way they bond? The same. They have similar chemical properties, right? So then if I know that ClO3 is chlorate, what is BrO3 going to be?
Bromide.
Not bore. That borate would be up over here with the
Bromate.
boron. It's going to be bromate. If ClO3 is chlorate, BrO3 is bromate. What would iodate be, besides a miracle? Iodate. At least that, when in high school, that was for sure. But, you know, anyway, I won't even go there. My poor high school. Okay. Iodate would be what? IO3. They're all going to be exactly the same. Okay? So if sulfate is SO4 minus 2, what's selenate going to be? SeO4 minus 2. And tellurate's going to be TeO4 minus 2. So what would tellurite be? Say that? No.
TeO3.
TeO3 minus 2. Okay? So if you know one in the family, you know the whole thing. So I can say that hypoiodite, well, hypochlorite is ClO minus. So what's hypoiodite going to be? IO minus. Okay? Now, all of those aren't on here, but the chlorates are all on here. Okay? So if I know the chlorates, I know the whole family. If I know the sulfur, I know the whole family. If I know the phosphorus, I know the whole family. Now nitrogen and carbon do their own thing up here. Okay? Here's the other thing that's going to blow you away. What's the charge on nitrogen family? If it's just a monatomic ion, it's all going to be -3, -2, -1, right? Well, the polyatomic ions are going to be the same. Phosphate is going to be PO4 -3. Phosphites, PO3 -3. Arsenate is going to be ASO4 -3. Arsenite's going to be ASO3 -3. Sulfide is S -2. 2 minus. Well, sulfate are both 2 minus as well. All of these are all going to be -1. chlorate, chlorite, hypochlorite, chloride. So these are, and if this is in the polyatomic ion, they're -1. If this is in the polyatomic ion, it's -2. If this is in the polyatomic ion, it's -3. So periodic table tells you everything. National Periodic Table Day. Look at what is, that's why it ought to be National Periodic Table Year. Okay? It needs to get the, it's such an incredible thing that you can tell from it. Okay? So let me go ahead and give you this ion sheet. This is yours to keep. And I kind of, everything that I just kind of said, okay? Here's your chlorate, chlorite, perchlorate, hypochlorite. Bromine and iodine form the same type of ions. They're in the same family. So again, CiO4 is going to be periodate. So again, if you know the one, you can know them all. Okay? Group 17 is always -1. Group 16 is always -2. Group 15 is always -3. So we can just kind of always know elements in the same family. So we come down here on this part down here. So phosphate is PO4, so arsenate is going to be ASO4. The same family, everything's going to be the same. So arsenite would be what? ASO3, 3 minus. Selenate and tellurate do the same thing, so we can always follow these. Okay? All right. So, again, you're so fortunate. I used to make everybody have to memorize these. You didn't get this on the test. Now you get it on the test. Okay? So let's look at practice. Let's see then how we name these and follow these rules. So we're always going to name the cation first, and the cations, the positive thing's always going to be written first, and then we're going to name it first. It's a life lesson. We always want to be positive first, negative as a last resort. Positive in the formula and the name always goes first. You're always going to have a positive thing and a negative thing. You don't have two negatives come together. You don't have two positives come together. Nature, opposites attract. Positive and negative. And so here's my positive thing and here's my negative thing. So we're going to follow the rules. It's real simple. You name the cation first. But you have to say, does sodium have more than one oxidation state? No. Okay, I know that for two reasons. Number one, it's an alkali metal. But plus, when I look at my periodic table, it's only got one little number 1 above the symbol. Okay, so I do not need Roman numerals. It can only be one possible thing, so I don't have to state what that is. So I'm just going to name the cation first, sodium. We don't change anything. And because it's monatomic, what's it going to end in? So it's going to be sodium chloride. Okay? Monatomic. That's why we have the "ide" suffix. Okay? So the next one, the positive thing is calcium. Now, even though there's two fluorines, there's still just one type of element, so it's still considered monatomic ion. You just have two of the monatomic ions. So is calcium, does the calcium have more than one oxidation state?
No.
No. So I don't need a Roman numeral. Okay? So I'm going to just say calcium. I'm going to write it over on this side because I'm out of room there. Calcium. Okay? And again, it's monatomic. So what's it going to end in?
Fluoride.
It's going to be fluoride. And notice the spelling. Okay? It's UO, not OU. If you spell it FLOUR, that's flour. That'd be fluoride. Fluor, it's fluoride. But now we look at this next one. Now look, it looks pretty complicated. But remember, polyatomic ions are groups of atoms bonded together, but they act as a single unit. So my positive thing is the calcium, my negative thing is the phosphate. So does calcium need a Roman numeral? We already decided that. No, it's only got one possible oxidation state. So I'm just going to name calcium. And then I look on my sheet, PO4. I have to recognize that that's a polyatomic ion. That's not phosphorus tetraoxide or anything. PO4, what's the name of PO4?
Phosphate.
Phosphate. So I just name the cation and then the anion last. So it's just going to be calcium phosphate. Now, we'll have to just say these are not proper nouns, so you really don't have to capitalize the first letter. I just have ultimate respect for the chemicals. I just, for some reason, I always maybe it's because the symbol is capitalized, so I feel the need to capitalize. But the reality is they're not proper nouns. All right, so now here we go, though, a little bit different. So now I look here, iron right here. Iron is my metal, so here's my positive thing, here's my negative thing. Does iron have more than one oxidation state?
Yes.
Yes, this is why we have to know how to do oxidation states. So I need to know what charge then is it. Iron can be +2 or +3. So I got to figure out which one it is, because I can't just say iron chloride, because there's two possibilities for iron chloride. So I have to go through and look. So what do I know though? Chloride's oxidation or charge is going to be. Chloride's a halogen, right? So it's always going to be -1, but we have two of them, so it's going to be -2. Therefore, iron is going to be +2. So what's the name going to be? Iron.
Chloride.
Roman numeral 2 in parentheses. So on those rules that we talked about as far as naming, if the metal is a transition metal with more than one, you have to use a Roman numeral in parentheses to state the charge. Okay? So you might want to maybe put a star by that little rule and make sure you pay attention. That's the question that you always have to ask yourself on these ionic compounds. Iron 2, and then what's going to end it?
Chloride.
Chloride. Okay? If it's going to have an 8 or an 8, it's going to have an oxygen with it, which we'll see. Well, like the phosphate, we have oxygen here. That's why it's an 8. So what is number 5 going to be then?
Iron 3.
Iron 3 chloride. Okay, because it's -1 -3 has to equal 0, so this is going to be +3. So it's iron 3 chloride. Are y'all seeing this? And here's going to be the tricky one here. The Roman numeral tells me the charge, not how many there are. So when I'm looking here, is copper a transition metal? Does copper have more than one oxidation state? Really is how I can answer it. Yes, it can be +1 or +2. So I have to decide which one it is. The Roman numeral is not going to tell me the subscript, it's going to tell me the charge. So what's the charge on oxide?
-2.
-2. No, it has to equal 0. So what's the total positive charge have to be?
+2.
But how many coppers do I have?
2.
2. So what's the charge on each copper?
+1.
+1. Are y'all following that? So what's the name going to be?
Copper 1 oxide.
Copper 1 oxide. The Roman numeral tells you the charge, not the subscript. The Roman numeral tells you the charge, not the subscript. So it's going to be copper 1 oxide. So what's this one going to be?
Copper 2 oxide.
Okay? Michael's got it. The rest of y'all got it?
Yeah.
Okay? Phil, you got it?
I think so.
Because it's -2 + 2 has to equal 0. The Roman numeral tells you the charge, not the subscript. So if it's a metal with more than one oxidation state, we have to figure out what that oxidation state is. That's what we learned yesterday in practice, even first thing today. We have to be able to figure out the charge. We use the ones we know for sure to figure out the one that can be a variety. Okay? So one more, let's just look at one more. This would be number 11. Okay? And if I just said it was going to be, it's going to be, I want to do a complicated one. Come on, Steve, you can do this. SN SO4. SN SO4. Does SN10 have more than one possible oxidation state?
Yes.
Yes. So here's my positive thing, here's my negative thing. So rather than just looking at the sulfur and the oxygens, we recognize that this is sulfate. So what's the charge on sulfate?
-2.
-2 on this whole thing. Okay? Not just on the oxygen, the sulfate has a -2. Since it's one of these and one, and I'm going to put a parenthesis, but we really don't need it, but I'm talking about the polyatomic ion, it's a 1-to-1 ratio. So what must be the charge on this tin? If this is -2, it still has to add up to 0.
+2.
This has to be +2. Now again, if you look at tin can either be +2 or +4. But we use a polyatomic ion, we use the charge on the whole thing. We don't worry about the individual oxidation states, we use the charge on the whole thing. Okay? So, we're going to call this tin 2 sulfate. Tin 2 sulfate. You use the charge on the whole polyatomic ion. Alright? So if I said then, we'll go number 12, AuNO3 3. AU, that's not your gold. A Spain Park grad though went and made a ton of money on selling a t-shirt that says AU is golden. You know, because AU is gold, and then Auburn, he went to Auburn, he sold the t-shirts at Auburn saying AU is golden. Just a creative mind, he sold a lot of those t-shirts. So does gold have more than one oxidation state?
Yes.
Yes, what are the two possibilities?
+1.
+1 and +3. Okay? What's the charge on nitrate?
-1.
-1. So treat the polyatomic ion as a single unit. It's -1. Since I have 3 of them, what's the total negative charge? -3. So gold must be +3. So we're going to say gold 3 nitrate. Okay, now we're going to have a lot of practice on that, but that's when you have when you have a transition metal or a metal with more than one oxidation state, you have to use the Roman numeral to tell what that charge is. That's why we had to learn how to do oxidation states first. Okay, so we have to just always get that charge. Positive things first. The Roman numeral only goes with the first thing. The Roman numeral is only for a metal. The Roman numeral is always the positive charge. The negative charge can only be one thing. That you have all the charges on your ions. Okay? Alright, so now let's go in reverse. Turn the page. Instead of naming, let's write formulas. We're just going to use the exact same principles, just in reverse. Okay? So we're here. So which one goes first?
Positive.
Okay, which is called a what? Okay, so this actually we're going to say positive ion. Okay, the positive ion is called the cation. And the symbol for the negative ion last. Okay. Now, we're going to balance the charge using what we call the crisscross method. Crisscross. We're just going to, because how do you find the lowest common multiple in math? 2 and 3. What's the lowest common multiple? How'd you get that? Multiply, cross multiply. Right? Because we got to get the positive charge to equal the negative charge. So that's how we're going to get our subscripts. Is just we got to cross multiply, and whatever the charges are, we just got to make the positive equal the negative. So the positive charge must equal the negative charge, yielding a sum of, what do the charges always add up to? 0. Okay? If the metal, or I'll even say cation, is a transition metal with more than one possible oxidation state, the charge / oxidation state will be indicated by the Roman numerals. The Roman numerals are going to tell you the charge. So that's what I'm saying here. Chromium 3 is going to be +3. Copper 1 is going to be +1. Copper 2 is going to be +2. Iron 2 is +2. Iron 3 is +3. You're going to be told that if you have to write the formula, the name, just like we just had to determine the Roman numeral, if the name is given, the Roman numeral is going to be in it. Whatever the Roman numeral is, that's the charge. The Roman numeral given is the charge on the metal. Charge of the metal. You just gotta say charge. All right. So let's look at practice of these. And this is just lowest common multiple, and we're gonna run out of time a little bit, but we can get through most of this. We'll practice some first thing tomorrow, and then but don't put away yet. We're gonna go all the way to the bell. All right. So I want to write the formula for barium chloride. So the first thing is I say, okay, well, barium's 2+. Well, how do I know barium's 2+?
Periodic table.
I look at the periodic table. It's in the second column, so it's going to be +2. Plus there's a little number 2 above barium. Okay, and then I tell so barium plus chloride, it's a halogen, so I know its charge is -1. So I got to get the positive to equal the negative. So I'm just going to crisscross. Now I don't write ones and I don't write signs. But I know that if I have a +2, I need 2 -1s to balance out the +2. So the formula is going to be BaCl2. Because now I have a +2 and a -2 equaling 0. I'm just cross multiplying, but again, hopefully you know that the lowest common multiple of 2 is 2. So now I have a +1 and a -2. So I gotta make the positive equal the negative. So if I have a -2 here, how many of these +1s do I need to make it balanced? 2. So I mean crisscross, I'm doing this, but it's so simple, we can just say Na2O. I mean, most of the time you just do that in your head. So now we go to magnesium sulfide. Well, what's the charge, symbol and charge of magnesium? Mg +2. Sulfide is going to be S with what charge? -2, because everything in that family is -2. There's only one possible negative. So it's just +2 -2. It's already equals 0, right? Now look, the ionic compounds, what type of formula do we use with ionic compounds? Empirical, which means what? What are the ratio? Simplest. So we're not going to say Mg2S2, 2 to 2, what do you call it when it reduces to what? 1 to 1. So in other words, if it's +2 -2, if it's already equal, you don't do anything, it's just MgS. Okay, but here, iron 3, what does this Roman numeral tell me? It's charged, so it's got to be iron +3. Oxide is always going to be Oxygen's always going to be what? Minus 2. So this is where we have to get the lowest common multiple. We crisscross. So 2 times 3, so it's going to be Fe2O3. Because now we have plus 6 and minus
Do you
6.
have to put the plus 3 above FE?
No. You don't. All you have to do is get to this. If you can do it in your head, that's fine. So y'all have a great weekend, and go Jags.